Good evening, folks. How are you? Cool. You guys know I can see you. You can respond and nod and smile and yes. My name is Aaron Lohr. I'm the chair of the Computer Society, the Silicon Valley chapter, and I am very glad that all of you made it to our alternate location this evening. If you guys normally join us, we're usually over at the Cadence building, but I'm glad to see that everybody made it over here. I hope nobody got too confused and headed back over to the other spot. We'll be back there our next talk, which actually is coming up on July 18th, I believe. I think that's the Tuesday that we're going for. So July 18th, I believe, is our next tech talk, and there will be an email sent out to let you guys know about that very soon. So anyways, tonight's agenda here, we're glad that you're here. Networking, announcements. We'll have our presentation here in just a moment, and then we've got to clear out of here. We've got to be totally out of the building and stuff by 8:30, so we're going to kind of close things down probably a little bit after 8 o'clock or so, and we'll get out of here, okay? If you guys are not part of, actually, how many of you guys are actually part of IEEE? IEEE in general? Excellent. Tons of people. And how about the Computer Society specifically? Excellent. Right on. Excellent. Oh, fantastic. The Computer Society is actually a separate membership, if you guys weren't aware of that. It above and beyond your regular IEEE membership, and because of that, the extra dues that you pay to be part of that additional chapter there actually go to help pay for things like this talk tonight, all that pizza. And there is a ton of pizza left. So if you're not eating pizza, you should be. If you have already had pizza, eat more. We should, yes, we should. Yes, we've been, and actually, we do have a little calculator thing that we use. This is a little behind, inside baseball for you guys. We do have a little pizza calculator that we use, and I even shorted that order, and we've still got this much extra pizza. So yes, there needs to be a little bit of revision on that. Maybe there will be an email about that. Anybody wants to help out with our pizza calculator. So anyways, lots of other benefits and things that you get with Computer Society, so I'd highly encourage you guys to take a look at it, check it out if it is something that you might want access to. There's a whole bunch of different benefits and things. It's actually also like IEEE. It's sort of a subsection of IEEE. It's also a national organization as well. So there's talks and conferences and things. In fact, we've got two more conferences coming up this year. Earlier this year, we did NFIC that we helped out with. Those aren't directly like part of our chapter, but we're definitely very, very, very much involved in all of those. So we'd love you guys to get involved as well. Your Computer Society officers, that's myself at the top, and then Prakash, Sachin, and Krishna are all here. If you happen to spot any of these people, well, you can say hi to me, and the other ones you can smack them around a little bit or something. So anyways, please turn your cell phones off. I think I haven't checked here. Cadence usually has some sketchy signal, so usually it's not a problem there. But if you guys have signal here, please make sure that your cell phones aren't going off during the talk and things. We have a number of volunteers that help put this entire thing on, and the other group that I wanted to thank is actually our friends here at TI, the SSCS chapter of IEEE, also by hooking us up with this fantastic room. So let's thank all of the volunteers and TI especially. Thank you very much for letting us do our talk here. We really appreciate that. Kind of just couldn't quite put it together, and so these guys kind of came in and saved us. It looks like we've got a whole bunch of folks coming in a little bit later, so if you guys have an open seat or something, if you guys can kind of squeeze together, if there's an open seat next to you or something, there's a bunch of people that are coming in, so please, kind of, if you can, scoot over, get cozy. Would appreciate that. Thank you. All right. Now, I actually have a little bio to read. There's a bio, yeah. There's bio and accomplishments and everything. Dr. Mohan has been an IBM researcher for 35 years in the database area, impacting numerous IBM and non-IBM products, research and academic communities, standards, and especially with his invention of the Aries family of database locking and recovery algorithms, and the presumed abort commit protocol. He's a fellow of IBM, IEEE, and ACM, served as the IBM India Chief Scientist for 3 years, recipient of the ACM SIGMOD Innovation Award and the VLDB 10-Year Best Paper Award. He's received numerous IBM awards, as well as being elected to the US and Indian National Academics of Engineering. He's been named an IBM Master Inventor. He is an inventor of he holds over 50 patents. And he's here to talk to us. So, isn't that? Anyways, let's please warm welcome to Dr. Mohan. Thank you.
Thank you. Thanks, Aaron, for the nice introduction. If you don't mind.
Sure.
If you double click the picture. Got it. Thank you. Gives me great pleasure to be here. Okay. That URL at the bottom, there you will find lots of information. So, please record that. And also, if you go to my Twitter handle, you will see the link to such things. And so I'll post this version of the slides soon. You will find a slightly older version. If you see the top, it says, this is a revised version of the talk I gave a couple of weeks ago in Atlanta at the International Conference on Distributed Computing Systems. I keep revising it. That's the reason it's better to, if you're citing this whole thing, cite that URL, because I keep posting here links to videos and such things, and also a list of references that you will find very useful if you get interested in this topic, if you aren't already interested in it. What else do I want to tell you? Yeah, I also have this Tsinghua University connection, so I saw some Chinese people coming in, so they might get excited about that connection. Okay, so I revised the slides compared to the previous versions because I was giving it at that ICDCS conference. So I put these two charts that are coming up to just give a historical perspective on how in the 35 years I've been at IBM, things have evolved both in the distributed computing space and the database space. Interestingly enough, when I joined IBM is when we had an IBM Almaden. By the way, the research lab that I come from is the birthplace of relational databases, SQL, hard disk drive, and manipulating atoms one at a time and so on. So we work the whole spectrum, highly exploratory, where we don't know what the heck this will do to IBM's bottom line, to things that actually have great deal of impact on IBM's bottom line. So there were people working on Byzantine agreement protocols, clock synchronization, very famous people, Danny Dolov and Barbara Simons, who later became the ACM president, Ray Strong, a whole bunch of people. Some of them are now in other places. And at the same time, I was part of the R-Star distributed database project, which was a follow-on to System R. So I had worked on this two-phase commit protocol that was mentioned as part of the bio, presumed abort, which became part of international standards and so on. So I actually worked with some of the people doing the Byzantine agreement protocols to combine the two to make the two-phase commit stuff become even more tolerant of intentional faults and so on, not just system failures or link failures and such. But if you look through this list, you will see that over the decades, and I personally have actually worked on a bunch of them, like MQ series, which was IBM's messaging system, transactional queuing and messaging system. And there they used the Aries commit recovery protocol that was referred to, in addition to that thing going into DB2 and such products. Also, there was a work on transactional RPCs that some people like, for example, Alfred Spector and company at CMU did. In fact, just on Saturday night, the AFS group got the this year's ACM Systems Software Award at the function in San Francisco as part of the Turing 50. And then, of course, PubSub and such came. And then distributed event-based systems. And of course, then came client server and mobile computing and service-oriented architecture. I personally worked on workflow management systems. The reason I'm giving you all this is because, as you'll see, blockchains combine a whole bunch of these sorts of things. And some people have characterized blockchain as the second coming of the internet. There's a father and son team who put out a book. I heard the father speak for an hour about this topic based on the book that came out recently. You'll see a citation later. And then if you look at the database space, when I started, Ted Cord was still part of our group in IBM Almaden. We were called San Jose Research Lab at the time. Cottle Road was the original location. In '86, we moved to the current location. And that's the year, '81, is when he got the Turing Award for his relational work. And as I said, I was part of the R-Star project where we worked on all sorts of stuff that have to do with distributed versions of relational database systems. And of course, we even worked on replication, both synchronous and asynchronous replication, long before all the recent hoopla with NoSQL systems, eventual consistency. These things have been dealt with decades ago in the context of relational system. Update anywhere replication was part of many relational systems. And Lotus Notes also, on day one when it came out in '89, had support for disconnected operation and, with updates being done in parallel against the same data when they were disconnected, then having to be reconciled when you reconnect to the network and so on. And of course, in the context of relational systems, Sybase was the pioneer with respect to introduction of stored procedures. As you will see, the smart contract logic can be thought of as a stored procedure executing. And then, of course, object-oriented databases came along, and they introduced, also there was the XML revolution, and then now, of course, everybody's excited about JSON. It's all squinting of the eye with respect to, whether these things are really fundamentally different or they are variations on, XML and such. Of course, with Web 2.0 came all this focus on massive scaling, and sharding is used as if it's like a brand new concept. Partition tables have been around in mainframe DB2, even in a single system context, in order to, put different fragments on different kinds of devices in terms of their speeds and such. But in any case, of course, the NoSQL revolution resulted in utter chaos with respect to no standards being there and every system having its own API. And then, of course, came the, in some ways, a giant leap backwards for mankind, going back to pre-relational era with MapReduce and low-level APIs and, programmers being left to their own devices to deal with the crap that the database system was supposed to deal with. And that was the big thing about relational and why it's good for humanity and so on. All those decades of mantra that was recited all got thrown out through the window, baby with the bathwater kind of thing. And then, of course, cloud resulted in all sorts of issues like multi-tenancy and trans-border data flow restrictions and all that, having to be worried about privacy and, of course, multi-data centers. And, of course, along the way came things like Spanner by Google, which talked about synchronous replication across the whole globe, performance problems coming from synchronous replication with two-phase commit. Two-phase commit was dissed a lot in between because people thought, it'll result in increased response time and who needs that, and we can make do with eventual consistency and so on. But even the smart-ass guys in Google and Facebook and so on have figured out that it's too much of a pain to deal with the aftermath of inconsistencies, and so they are now advocating. The way Facebook did that was when they were looking for a persistent store for messages, they chose to go with HBase rather than Cassandra and such, because they wanted synchronous replication and avoid the inconsistencies. Okay, so much for all this history business. What are blockchains? Blockchains originated with digital currencies, also known as Bitcoin. It was the handiwork of a guy whose identity is not known. He has a Japanese name in the paper that he wrote, but nobody knows who the real human being is that was behind this work. We are not interested in the cryptocurrency and the open blockchain world. We are more focused on private blockchains or permission blockchains dealing with business-related stuff rather than trying to, go around the traditional currencies and all that the crypto people are excited about. It's currently a big thing in terms of any kind of organization you can think of. It's not just, geeks in Silicon Valley being excited about it or only university people. Any institution you think of currently is debating, exactly how they should leverage this technology. So blockchain was the underlying technology of Bitcoin, and we are interested in that underlying technology rather than what it has been used for in that context, which was to essentially manage one currency. And of course, there are some consortia, we'll talk about them, Hyperledger and Enterprise Ethereum. There are now commercial deployed versions of blockchain technology in production usage. First one was what IBM did for this outfit called the Northern Trust, which is a Chicago-based entity, but Guernsey is where it was implemented. This is an island off the English coast, and it's being used for managing private equity funds. So this is not your, system for managing New York Stock Exchange transaction rates and so on. So for a transaction guy who has spent, 35 years at IBM, plus even my dissertation was in this topic, the rates in terms of number of transactions that these systems deal with is minuscule compared to the millions of transactions and so on that the TPC kind of crowd normally talks about and worries about and so on. There is a service that's made available by IBM, which is called the High Security Business Network. This runs, believe it or not, on a mainframe with Linux as the operating system. And it was announced at the Interconnect conference in March as blockchain as a service. And it's considered the highest security system anywhere because it leverages the SGX enclave equivalent in the mainframe, a secure execution environment, and it also takes advantage of hardware features for doing encryption and such. So it's super duper in terms of that sort of industrial strength type features. So what's the big deal with all this? So the way this thing works, in the traditional way of doing a transaction involving multiple parties, each of the parties has its own record of what's going on. There isn't a single source of truth. And then, even think of buying and selling a house. Neither party might know the other party all that well. And so you have an intermediary like an escrow company acting as the one that guarantees certain things because neither one trusts the other one. And even money transfer across country boundaries and so on involves typically long delays and such. So there are lots of issues that crop up in this kind of scenario, and which makes it very inefficient, expensive, and vulnerable to fraud and so on. You'll see some more, pictures later as to how, in the case of supply chain and things like that, or even transporting goods from one place to another, there are way too many parties involved, lots of paper documents and this and that. Whereas the blockchain way of doing it says all these participants in a particular smart contract will agree upon what the rules of the game are. There's a piece of code that's written that embodies these business rules and such, and everybody executes that. They all take part in it actively to say whether or not they are in favor of a transaction being committed. And all this is recorded in an immutable fashion in what's called the blockchain. Think of it like a traditional database log, but it has more to it than what the traditional database log normally contains for recovery purposes. And there are protocols involved in guaranteeing that everybody is in agreement, or at least enough people are in agreement that there isn't any mismatch and so on. So there are consensus protocols. This has to do with like two-phase commit and variations on all that, which is the kind of Byzantine agreement protocols that I referred to that were the rage in the early 80s. And even people like Barbara Liskov at MIT came up with variation on the original thing that Leslie Lamport did, called PBFT, which we'll refer to later on, Practical Byzantine Fault Tolerant Protocol. And so the database itself is a mutable database, but the recording of the transactions that were performed, what each transaction did, is done in this sequential file effectively, which is a block of transactions. For each transaction, there is a description of who participated in it and who all agreed to that transaction being committed and things like that. There's lots of detail, and unfortunately, I don't have too much time to discuss all the details, so I'll skip over some of the material, and if you're interested, go read it. Even if you listen to my own presentation with the same set of slides another time, you won't necessarily hear the same thing being said, because I keep covering different parts of the presentation, so don't think that just because you've heard it once, there's no point in listening to some other recording that's posted at some point. So just to give you a feel for the sorts of things that go on, look at this: airports records, banks records, ports records, ocean carriers records, authorities, people who do inspection, like the guys at the customs and so on, or some other kind of inspection that's being done to make sure you are not transporting arms and ammunition and things like that, right? And then the airlines' own records. So even in a business of just transporting something from one place to another, especially if it's across country boundaries, so many things come up. And these pieces of paper that are given get lost and things like that. So we are trying to bring more rigor to the way in which all this is being managed. That's the big picture view of what's this way of doing business is all about, and why there is so much excitement about it, because people feel that this will bring about more uniformity and accountability and reduce friction and ease the business in terms of how long it takes for something to be accomplished. And if something does go wrong, you can more easily trace where the problem might have been and things like that. Okay. So this just goes into more details of the fact that the ledger is, think of it like a financial ledger. In a bank, even if some transaction that was done a while ago is found to be wrong, you don't go and change the original entry. You put a new entry saying this is a correction to the original entry. Whereas here, it's a distributed ledger because it's across multiple parties who can be physically across the globe and things like that. And also there are rules about who gets to see what, and so the privacy considerations are there. Cryptography is leveraged quite a bit. I'm not going to get into many of those things here, but there is enough stuff there that, unlike in an open blockchain, where random people can get in without having to reveal their identity and so on, here in a private blockchain, you have to be admitted to the party to participate. And as part of admission, you are, and again, it's rules of that they chose to enforce. Whoever is the one that set up the network as to exactly what all they want to get from you to let you in, whether it's your true identity or whatever, what kind of proof they want is all up to them. It's not like we determine all that as the builders of such a system. So the smart contract, as I said before, think of it like a transactional program. It can be multiple programs invoking one another and so on. There's things like, abstract data type concepts embedded here. Each program is manipulating certain set of data, and if you want to read or write that set of data, you have to invoke that program. So encapsulation is there in that sense to also make sure that people don't from different places get at the same data, and problems come because the enforcement of certain rules is not there and things like that, which is the same complaint I had earlier about NoSQL systems and such, where if you leave it up to the application to enforce a lot of constraints and this and that, it's subject to errors being committed by the people who don't know what they are doing and things like that. Whereas if you were to store those constraints in the database system, then the database system can be made to enforce them independent of what the users think they are doing or not doing and so on. And also there is this notion of a network verified transaction, because as you will see in details, there are various steps we go through in executing a transaction, and that then gives opportunity for all the important people, at least in a transaction, to say yay or nay with respect to whether or not they think certain rules that need to be enforced are being enforced and such. So broader participation, lower cost, increased efficiency, and so on. So just to give you a very brief picture of how things go, you have the notion of an application running on a client machine with an SDK. The blockchain developer develops the application as well as the smart contract. Think of this like a stored procedure running on the server side, whereas this is the normal application that you can think of in a SQL environment. And so this application is used to invoke the smart contract. Think of that invocation as triggering the start of a blockchain transaction, and for the time being, map each blockchain transaction to a corresponding database transaction. As you'll see, to begin with at least, some NoSQL systems have been used, which don't even have the notion of transaction in them, like the ACID transaction and such. But IBM has managed to still, have this other notion, the blockchain transaction notion, with all its atomicity and all that being guaranteed, even though the underlying database store is not necessarily ACID transaction compliant, because of the way in which a lot of these things are being done today, which is pretty inefficient in the sense that one transaction at a time is being executed. So even if you have failures in the middle, we are still able to clean up the mess and things like that. And so this invocation of the smart contract in turn emits certain events, hence the reference to the event-based distributed systems and so on. And this smart contract might invoke other smart contracts, or it might do database puts and gets, okay? And as I said, the blockchain itself is listing what the transactions were that were executed, whether each one was ultimately committed or aborted, and some additional information that we'll get into, read sets and write sets and things like that, who bless the transaction to go forward and things like that. And the puts and gets are really mucking around with the data in this database, okay? The sophistication level of this database and all that is subject of future research and all that. I'm personally working on, providing a relational database as the state database rather than the key value store and the document store that Hyperledger Fabric version 1 supports, which is LevelDB and CouchDB at this point. What else? So also, as these blocks of transactions get dealt with, information about, for each transaction in a given block, whether it committed or aborted, is also emitted as an event. So the client who submitted the transaction, unlike in a traditional system like IMS and such, where it's a synchronous transaction execution, the client gets back immediately at the end of the transaction a return of this original invocation which says the transaction committed or aborted in a traditional system. Whereas CICS is a queue transaction processing system. There, you get back the response as a message. Here also, it's like that. It's an asynchronous execution of what got invoked here by this guy. You don't get back a response code right away that says whether the transaction committed or aborted. It takes a while before that will come back. And so you have to watch out for that even. You subscribe to the event using the handle that you got back when you invoke the smart contract. It's like a transaction ID, if you like. Okay, I think I've said enough here. So we call this smart contract, at least in the Hyperledger Fabric, chain code. You can map it to stored procedure, whatever you like. And so this node in which all this is executing is called a peer node. There'll be multiple such peer nodes that will be involved typically in the execution of a blockchain transaction. I'm trying to stay somewhat general and not refer to only the IBM and other company consortium-based project, which is the Hyperledger Fabric. As I said before, there is Enterprise Ethereum and various other things we'll get into. So this notion of a smart contract is something that the Ethereum guys came up with as a generalization of Bitcoin. That was a separate effort that preceded the Ethereum work. But the Ethereum way of doing business still had the, if you like, the bad aspects of that original Bitcoin approach, which had to do with being open, being also having this notion of proof of work, which involves solving a math problem. These guys burn up MIPS like crazy doing this silly math thing. In this day and age of green and all that, there are server farms that are supposed to be in various parts of China, for instance, that do the so-called mining, which is not really useful work. It's just a way of doing consensus. So I couldn't care less about that aspect, even though it's intended to deal with Byzantine faults and such. In terms of efficiency, it's really, really bad. So we are now going to, make use of other kinds of ways of doing consensus that's a lot less expensive in that sense. And also, the original way of doing business meant that a transaction commit will take about 10 minutes or so to be finalized. We don't like those sorts of consequences also of the way in which Ethereum and Bitcoin have operated for a long time. I don't have time to go into the details, but I'll let you go at your leisure, look through these infographics to see what's going on. So this just gives you the history of how things have evolved, starting with the foundation days to moving beyond the cryptographers to blockchain buzziers to crossing the chasm, adoption, and then accelerated adoption. There's lots of very useful stuff here. I've stolen these slides from various places, and I try to give credit as much as possible, unless I overlooked something. So we are at, if you like, the peak of adoption, kicking the tires, and all sorts of vertical domains in which prototypes are being done and things like that. And as I said, there has been also a few instances of things going into production. There are some myths about all this, and the reality and the myth are indicated here. Whether, a blockchain is useful only in a cryptocurrency environment, obviously not. So it can be used to manage any digital or physical asset. And the interesting thing is physical assets can still be dealt with, and forgery and all that can be detected based on using some additional technologies that we'll get into. And one of the exciting ones is Everledger, which is used to manage diamonds. And we'll get to that. And then there are these sorts of surveys that the McKinsey kind of people do with financial institutions, which talk about where they are. They surveyed, I believe, 50 people. No, not 50. I think 100 maybe. Institutions, and this is what they found. I'll let you go look at this at your leisure. This is how things have evolved. Somebody asked me earlier about something not so good about Bitcoin and all that. That's the sort of thing. There's a lot of black money and this and that, some shady transactions that have been done because of the anonymity provided by Bitcoin way of doing business. And clearly we are not interested in such things at all. So interesting point here is that between 2016 and 2017, according to this article in the American Banker, there was certainly a sea change in the attitude about, it's 10 years out to, oh, wow, it's not as much out into the future. It's actually beginning to have even more immediate impact. And then there are various consortia, as I said. The one that got announced fairly recently, the new kid on the block, is the March one. That's the Enterprise Ethereum Alliance. So it's trying to add to the original Ethereum these private blockchain and all sorts of other better ways of doing things and more privacy and things like that. The original approach also had the problem that anyone that's part of the network, especially those that didn't even have to reveal their identity and so on, had full access to everything that was in that blockchain. So there was no attempt to, have privacy and this and that, which is again an aspect of the open blockchain that a lot of us have problems with. So the Hyperledger one is the one that IBM has been behind, initiated it, and that at this point, at least according to this publication, has the largest number of members in it. There are some companies or other kinds of organizations that are in multiple of these consortia. So at this point, there isn't anything like SQL in this space, believe it or not. Each of these consortia has its own way of doing business, and that's the sad aspect of it, if you like, that there is a bit of chaos here, and obviously what you wrote for one way of doing business won't work in the other way of doing business across these different consortia. So portability of your chain code is not something that is possible at this time. Okay, So just to give you some kind of indication of the adoption, and this is now specifically talking about Hyperledger Fabric, not any of the other guys. Look at this, 14% in financial services survey of 200 expect to go into production at scale with blockchain this year. And then 400 plus client engagements of the IBM blockchain team. This is now IBM as opposed to some of the other members of that consortium doing things. And 4 have been launched. IBM itself in global finance is using it to deal with the different parties. And also Everledger is that diamond handling company that I mentioned. Look at that, 1.2 million diamonds today are on the IBM blockchain, that high security business network that I mentioned before, because of that one company. It's interesting how even blood diamonds and any forgery and such can be dealt with in this environment thanks to the use of blockchain. And as you can imagine, there are many parties involved, right? From the time you mine something to the time it lands up on somebody's finger. In fact, the other day somebody joked that maybe you can track how many fingers the guy tried to put it on before it got accepted because some people didn't agree to the proposal and things like that. And SecureKey is a bunch of banks in Canada, I believe, that have also used this in an, I think it's the know your customer kind of environment. So here is a laundry list. IBM itself, and in particular, the IBM research labs, which are spread across the globe, almost actually every continent has an IBM research lab now. They are involved in various projects involving real customers. In some cases, they are mimicking the customer's environment within the IBM systems as a prototyping effort, and then they will give it to the customer to try it out and things like that. So it spans a whole spectrum of application areas, vertical domains, and this is not even complete. In fact, somebody pointed out the other day, I don't have healthcare. Obviously, that's also being worked on. Some things like the DeepMind that the Google guys are doing, for example. So provenance management is an important aspect. Farm to fork. In China, we work with Walmart in tracking food. That's what's mentioned there. And then in the logistics space, the kind of picture that I showed before, Maersk, which is the world's biggest shipping company, I believe it's Norwegian, they're working with IBM. There was a very nice New York Times article a few months ago that dealt with this topic very nicely. So I strongly recommend you go look at that article. I have a link in my page to that article. Any kind of reconciliation, settlement and all that is dealt with very nicely in this way of doing business. The book that I referred to before, The Second Coming of the Internet, Father and Son Team, that's the one that's cited at the bottom. Okay, so this gives you some of the logos and so on. So, for instance, DTCC is actively working with IBM, Depositories Trust Something Corporation. I've forgotten what the first C is. That's a New York-based entity. So there are many projects that are going on. DTCC, I have the expansion there, Depositories Trust and Clearing Corporation. They selected IBM and Exoni and R3. So R3 is a different effort than the Hyperledger Fabric. And the Fabric itself is one of many projects under the Hyperledger Consortium, which itself is under the auspices of the Linux Foundation. And just like in Apache, a project starts out in the incubation stage. In Apache, then it graduates to top level. Here they call it active. So it turns out this is the first such project under the Hyperledger umbrella to go into that state. There is a company in Berlin that's called BigchainDB, and they have started from the other end, going from the database system and trying to add blockchain features to it, rather than coming from the top and using the database as merely a store, which is the way, at this point, the Hyperledger Fabric operates. So as you can imagine, database systems also do replication, as I said before, but the way this Hyperledger Fabric and some of the other guys do it, it's this distributed program that's doing its own management of the replicas. So this is a totally different way of doing business. And there is a lot more to come in this space, to figure out which is the best way of doing it and so on. So I'll let you guys stare at these slides because I'm noticing I'm running out of time. There is lots of information about different companies and different parts of the world. This picture is not showing the US ones, it's showing only the non-US ones. And it's not necessarily complete. Again, I got it from CB Insights. So this is an attempt by a group in National University of Singapore. They have come up with the first set of benchmarks. They call it a benchmarking framework to analyze private blockchains. And they have evaluated at this point Hyperledger Fabric, not the latest version, but the previous version, Ethereum, and there's one more. It will come up in one of the subsequent slides. That's actually a variation on Ethereum. The client is different. So if you look at this, at the top you see the blockchain, and that involves also a consensus layer, and some of the consensus protocols are mentioned there. I mentioned PBFT before. Proof of work is the original one that Bitcoin had. Then there is proof of state, there is proof of asset, and so on and so on. The Intel guys have come with something called, I think it's POET, proof of elapsed time. Okay, these are all variations trying to improve the performance of the consensus layer. And of course, they all are attempting to deal with Byzantine faults, in addition to traditional failures that you and I have dealt with forever, which has to do with nodes failing or links failing and things like that. And I've already explained a bunch of this stuff, so maybe I should just go forward. So there's input and output that's part of the invocation of a contract. The contract itself is mucking around with the state in a database. And this is happening at different levels. Even the execution environment of the contract is specialized in many cases. They have sometimes their own language, or at least the virtual machine might be different. It's like Java bytecode. They have their own thing in some cases. And Docker containers are also used. And even the language in which you program the smart contracts. The Hyperledger Fabric lets you do it in this Golang. I believe there's also a Java version. So there are many such differences. This is a Sigmod paper, and you'll see a reference to this in my page. There are various architectural and feature options that are there. We've already talked about some of them. Crypto versus generalized assets, and permission versus permissionless. What kind of consensus protocol? What kind of state database system do you use? NoSQL versus relational. Whether that system supports transaction concept or not. Whether that database that you are using only has the latest state of the items that you're manipulating, or it even has the versions of the items, meaning you can do temporal queries and do time walk and so on. Like PostgreSQL, for example, allows you to have versions, past versions also kept. DB2 with its bitemporal relations lets you do that also. And also there's this idea that if you have big objects, documents that are huge or highly sensitive documents, even social security number and such, because once you put something in this blockchain, it's there forever. So even though you can use crypto and this and that and control who gets to see it, some people are a bit nervous, or the performance implications might not be good if you have huge sized objects. So there is this idea that you can have an external store in which you store the real thing, and you store a hash of that in the blockchain. And that hash is there so that if later you access that external store version of the document, you want to be sure that it's the same original version as opposed to some tampered version. Then this hash that's in the blockchain will let you find out that it's not the original one. It doesn't solve the problem of getting at the original in that case, of course. That's the negative of that. So you are now in the hands of whoever built that system and whatever reliability it has with respect to being able to get at the original version. And then, as I mentioned briefly, even with the non-transactional store, we are still able to do certain things because there isn't a whole lot of parallelism in the way these things are being done. Even though all sorts of stuff is flying around simultaneously, multiple transactions are being submitted and all that, when the time comes at the end of a three-phase way of doing transactions, the last phase involves, at least today, transactions being done one at a time. And that's why failures can be more easily dealt with. And I'm not, as a guy who has spent his lifetime working on high concurrency database systems, not happy at all with this silly way of doing business. But that's the current state of affairs. So this is just giving you some history about how replication has worked in the past and how traditionally we use the log to do the reapplication of the updates that happen in one place in another place. But that means that the two places must have the same schema, same, page format, page size, and all this kind of stuff. So typically, that's like restart recovery being performed using the log records, but on a different location. That's done for disaster recovery. And within a node, of course, it's done for restart recovery. So you are using the log records as is. But the next one is the one where from the original log, from the primary site, let's call it, where the updates actually got performed by user transactions, you look at the log records and generate from them a SQL statements, which then get reapplied at the other site, which is a replica site or a backup site, whatever you want to call it, a target site. This way of doing business lets the target site have different schema, potentially subset of what the original data was. Some of the columns get left out, some of the rows get left out. The page formats can be different, page sizes can be different. It could even be one is DB2, the other one is Oracle, for example. That kind of differences will be fine. Because you are re-executing using higher level notion like SQL. There are lots of details about this that will be exciting for geeky people. I can discuss that offline. I don't have the time to go through it. But it also means that it can handle any kind of non-determinism in the original execution of the queries of the transaction, let's call it. Because it's the after effect of the non-determinism, what actually happened that gets captured in the log. And since that becomes a source for doing what you're going to do at the replica, you are not suffering what happens in the third approach, where they capture the original transaction and then they re-execute it. If there was a tossing of a coin that happened as part of the original transaction, then when you redo it from the high level up, then the tossing could result in a different value popping up the second time around. So, but that's the sort of thing that Mike Stonebreaker with his project called HStore, which is commercialized as VoltDB, does, and that has all sorts of other implications. They run one transaction at a time and things like that. And that's also a problem, although they do it in a distributed context, so they hope that in each node, if they execute serially, it's not still that bad because you have multiple nodes doing that in parallel, but then they hope and pray that most transactions are single shard transactions, that a single transaction doesn't touch multiple shards, in which case all hell breaks loose because they need a lot more synchronization and all that. And the serial execution has other problems. There's no priority-based scheduling. If a long-running guy begins, then you have to twiddle your thumb until he finishes before you can get going and things like that. Okay, this is the work I already referred to, which is the National University of Singapore benchmark. They have, OLAP and OLTP style queries or workloads to exercise different parts of this blockchain system architecture. They compared, as I said, parity is the third one, which is a variation on Ethereum. And they found that Fabric performed extremely well, but mind you, this is still with the old version where the consensus protocol is PBFT and it's pretty inefficient compared to what we are doing now in version 1, which is using just Kafka. It's not at this point dealing with Byzantine failures, but it's a pluggable consensus model. So you can plug in PBFT and so on, but out of the box, it comes with Kafka as the distribution mechanism for transactions. You can go look at this for more details. Okay, so Ethereum, as I said, originally came up with the idea of smart contract, and then it expanded the applicability of blockchain technology to business context and so on. But they also still have the notion of this currency called Ether. The more recent exciting thing that's happened is the announcement of this EEA, which involves players like Microsoft and JP Morgan and such. They are in the process of figuring out what they're going to do with all this. There's some more details here. But the one major decision that they seem to have made is that they will use Quorum, which was a set of algorithms and model and so on that the JP Morgan guys had been using for a while. They will base their private blockchain using that and the approach to how they manage the data and such. There are more details in all the things that are listed here. So just to give you an idea, what do I want to go say here? Let me skip this slide. The next slide shows a bit more of what's going on. Remember I said in the Bitcoin approach, whoever is in the network gets to see everything. This was the case even in the Hyperledger Fabric until the latest release, meaning even though we are admitting people based on, whatever criteria we choose to use, once you got admitted, you got to see all the transactions that were floating around. This was not considered good enough even in that environment, right? Even in a permissioned environment. So we have now introduced the notion of channels where, let's say you have 10 people. This is like a Venn diagram. Subsets of the people may be working on specific contracts, and they want whatever is happening as part of a given contract to be visible only to the participants in that contract. So that's the notion that this Quorum also has. So for instance, here you see green, blue, black, and gray. Those are different grouping of the peers. So there are transactions that are tagged with the color, which means that it's a transaction that involves the parties that are in the corresponding blob, if you like, the subset of the nodes. So here they have this notion that there is a public state that's visible to everybody and so on, and then there is a private state that's specific to a particular channel. We are calling it channel, I forget now what they are calling it. But the blockchain itself is the same one across everybody. I'm assuming in a given block in that single file, the block itself is probably specific to one of these colored things, but they are mixing up in a single blockchain transactions belonging to all these different channels. Whereas in our approach, you'll see that we separate out the whole thing. The channel is also separate for the different subsets of the people. The blockchain is separate for the different channels. And we don't have this notion of a public state. We have everything being private to a particular channel. So what this means is that a given transaction, let's say that's a green transaction, is here, here, here. That means these three participants are part of that green channel. And then if you look at this one, it's part of this. The blue one is involving participant 3, participant 1, and regulator, as well as participant N, and so on. It's obvious to see what's going on. Of course, this means that a given peer is part of more than one channel, and that's to be expected. It makes very good sense and all that. So the Hyperledger project, I've already said a lot of these things, so I'll skip this, but it basically came into existence in December 2015, and it got rebranded as Hyperledger project in February last year. So it was initiated with IBM contributing the code that was developed in our company. And since 0.6, so the previous releases were called 0.5 and 0.6, and version 1 is the latest, greatest, with major changes that have to do with the introduction of this notion of channel, and which improves trust as well as scalability and such things, because not all the nodes are involved in all the transactions, and as a result, you can better distribute the load and things like that. And even the consensus, as I said, there's modularity because you have a pluggable interface for the consensus layer. Similar story with the database also. There's a pluggable database interface. And okay, the other things, IBM also worked on something called Composer, which is to develop the apps. It's a high-level way of developing the chain code, and that IBM has contributed now to open source, and it's one of the other projects under the Hyperledger umbrella. And there are many customers doing trials and such. Okay. So elements of the architecture, we've already talked about a lot of these things, so I'll skip this. So there's a notion of a membership service, which is the one that gets involved in deciding whether to admit somebody or not, if so, what conditions they have to satisfy and things like that. Yeah, I think that's good enough. This gives you more of the view of the architecture of the whole system. Do I want to say anything? No, I think, there's this notion of a secure container and secure registry and things like that. There's a lot of, use of cryptography and things like that here. Just to give you an idea of the sorts of applications that people are dreaming up. In Singapore, there are a consortium of banks that are interested in the following, know your customer kind of application. I go to bank one, open an account, and as part of that, that bank asks for all sorts of documents to make me prove who I am. I don't know, my birth certificate, whatever, right? My home, location information, that some government document or whatever, and things like that. And then I walk to second bank, and they ask for a bunch of stuff, some of which will be the exact same things that the first bank asked for, and they might ask for something else also, proof of employment, whatever. It's a pain in the ass if I have to provide all this, all over starting from scratch. So wouldn't it be nice if the first bank puts its stuff on the blockchain, and then at my request, they can transfer those pieces of information to the second bank, and then I have to provide only the ones that I haven't provided to one that two wants, right? Here is a twist to this. First bank doesn't want the second bank to know that I am a customer of the first bank. And by the same token, second bank doesn't want first one to know that I am becoming its customer. But at the same time, we want to enable this transfer. And so it has to be done in such a way that bank 2 doesn't know where it came from, and bank 1 doesn't know to whom it's sending. But at the same time, it should be provable that what I gave to bank 1 is what bank 2 is getting. Okay? So they do all sorts of goofy stuff that I don't have enough knowledge of, which has to do with one-time use key and this and that. That proves all this stuff. So it's those sorts of things that people are excited about doing, which is supposed to improve efficiency and all that compared to old way of doing business. Like I said, this doesn't necessarily mean that the transaction rates are as high as what you are used to in a traditional transaction processing arena. This is like, 30 years ago, 40 years ago kind of transaction rates at this point. But they say, if I complain about it, they say I'm barking up the wrong tree, because compared to the traditional way of doing all these contracts and such, this is a much improved state of affairs, so don't complain. Okay, so at least with respect to our thing now, as I said, before version 1, only LevelDB was being supported, which was a really simple-minded key-value store. And in this release, we also support CouchDB, but it's still in some kind of beta mode. That's a document database. And so in this picture, we are showing that the transaction log has this blocks of transactions, where each block has a bunch of transactions. And for each transaction, there's this read set and write set, which says what items were read and what updates were performed. And the state database here, we are assuming, has the latest value for the items that are being modified. And if you want access to the past versions of those items, this approach says, we'll give you an index into the log, but this is not your traditional B plus tree value-based index. It's only saying, you are interested in item 13. Here are the different places in the transaction log you'll find changes being performed to that item 13. If you're interested in item 13 having a certain value, you have to go through all of them and figure out which one has the value of interest. It doesn't directly give you access to the particular transaction that caused this value to come into existence. Okay, so the way transactions are executed, so it's called endorsement, followed by ordering, followed by validation. So you submit the transaction. This is the SDK being used to send the transaction to the so-called endorsing peers. Exactly how many endorsing peers are there, and any given transaction, how many of these endorsing peers get involved is all like database design issues. We as the ARMS providers at this level of discussion couldn't care less exactly how that's done. We are allowing you to specify for a given transaction, what all are the requirements that need to be satisfied. Mohan is an important guy. He should always bless a transaction. Amongst the other 13 people that are part of this channel that are endorsing peers, it's enough if 5 of them, any 5 of them, bless this. Those sorts of predicates can be specified. And so the endorsing peers all get the same input. They execute the smart contract, but this is a simulation. They are not actually performing the updates in the database. They are doing the reads from the database, but the writes are not being sent to the database, but instead they are being captured by the fabric layer and kept aside. So this is like optimistic concurrency control. At the end of this transaction, the read set, and the read set has item IDs plus a version number for the items that were read, not the actual value. So this means that items are being numbered as they keep getting updated. Think of it like a lifetime number. And then the updates actual values, right? And then in the second phase, after this client satisfies itself that enough of these endorsing peers have blessed it, and that their read sets and write sets are matching, it then hands over the transaction to the ordering service, which randomly puts the transactions into a block. No, fancy logic is applied there. And then it sends it to all the nodes that are part of that channel, including the original guys, the endorsing guys. There are some nodes which are not going to be endorsers at all. They are merely validator nodes or committer nodes. Same term is being used. All they are doing is that they are keeping the database state. They don't have the program logic to even do the smart contracts. They are merely serving as repositories for keeping the state. They can serve as, read-only places for other people who are interested in extracting the information out of the database. And those guys, what do? They receive for each transaction the read and write set. They stare into their version of the database. If the data that was read still has the same version number, that means the value hasn't changed. They're not comparing values. They're only comparing the version number. Then they say the world hasn't changed with respect to those pieces of data. And hence, if the contract were to be re-executed, the output produced would be exactly the same as what was originally produced during simulation. So they merely install the updates. Everybody does that. You should immediately think, this means that they're assuming there's no non-determinism in the execution of the contract. Guess what? Yeah, it's true. In this approach, they've assumed that given a set of input, the smart contract will always produce the same output. That will be true only if there's no non-determinism. Okay, these are all more details. I won't bother you with all that. So there are a lot of database implications about how this is all done. Today, all the tracking is being done in that layer in between. It's not done with the database. It has lots of consequences because now that layer in between has to know the syntax and semantics of these database calls, which is not good. It also means that if you said change all San Jose employees to Almaden employees, and originally 10 guys qualified, if you don't re-execute the query during commitment, it's possible that there are now 12 employees who are actually San Jose employees. You'll still wind up modifying only 10 of them to be Almaden employees. So if you want to avoid this phantom problem, you would have to re-execute the query at the time of validation to see whether the number of answers you get is still the same as the original one. Right? With a simple key value store, this is not an issue because you're not able to pose queries of this kind that I just mentioned. You're only able to say, get me that object with this primary key, and here is the new value for it. And so these are all the more complicated scenarios that will come up as you generalize the language that you are using to manipulate the data and query the data and so on. So R3 Alliance is another one of these things. It again has a bunch of people working on it. They have even worried about JVMs themselves having non-determinism. It turns out between one release of the JVM and the next release, because of weird stuff, the answer you get could be different. So talk of, things being so crazy in this world that even at that level, there is non-determinism because of, I forget now what the particular thing is, whether cache line size or some interleaving of instructions and all that causes some weird behavior. There's a paper that talks about it. They have actually a relational DBMS support. I don't have all the details about it. And they have their own language also. There are all these various things that are so many, angles at which these systems are different. I mean, it's unbelievable. This is going into more details of how their thing works. I'm being given the hook, so I'm going to skip it. I mentioned this. It's a startup in Berlin. They started out with Rethink DB, a single cluster that's used by all the participants in this blockchain network, but they overlook some very simple things like somebody could drop a table and things like that. They're not protected themselves against that, so they got beaten up quite a bit in some of the blogs and so on. Some of the dumbest of things, that anyone with an ounce of database background and transaction background will have to worry about. So it's supposed to be immutable, but even basic things like that, they forgot. But more recently, they've started doing something with MongoDB also, not just Rethink DB. There is a MongoDB white paper that's floating around that says something. It's not clear exactly who's doing what in this space, whether Mongo guys themselves are doing it or these guys are doing it or some combination. They do have this interplanetary database network and a foundation for its governance. And that talks about some of the bigger things in life that they are worried about, privacy and things like that, reputation and so on. Okay, these are more details. I won't have the time to go through it. I mentioned this very briefly. The project is called Sawtooth. It's also under the Hyperledger umbrella. Intel is a major player in this, and that's where they came up with this thing called POET, which is considered to be a much more efficient protocol compared to proof of work and such, because of the randomness that they have in the leader election. By the way, one of the other problems with Bitcoin is that it doesn't guarantee uniqueness, meaning you can have a branching in your blockchain, whereas the way IBM and company have worked out all the things in our environment, we don't have any branching problem because of the way the consensus protocol works compared to the proof of work one where more than one winner could be there, and then they wait for a long time to see which is the longest chain in the branching ones, and then they declare the longer one to be the winner when there are these parallel things that have happened. That's a major reason for the 10-minute kind of delay in a transaction's outcome being known. Even that is still not guaranteed, So that kind of nuisance is there in the way it was done originally. So they obviously are also exploiting this SGX secure enclave in this system, which is similar to the one that I mentioned on the mainframe that's part of the HSBN product that IBM announced, blockchain as a service. Mainframe, of course, is super duper with all this. Ripple is another protocol that was developed in a specialized environment that wasn't necessarily thought of as a blockchain. This was for transferring money across banks. And by the way, it should have occurred to you that because this client is talking to these different machines and they are supposedly in different organizations, by definition, it all implies that all those peer nodes that are part of the blockchain network are in the cloud. Because if they are behind the firewall, this poor SDK cannot talk directly to that thing. And also even the ordering service is talking to all those nodes in the network, right? But somehow these Ripple guys have managed to put things behind the firewall. So things like this Ripple Connect is running behind this firewall. And then there's a HTTP proxy, and then similarly on some other institution. There's one institution, there's another institution. And they're talking about a database that's used in which the Ripple organization demanded schema is established. So they are dictating certain things, the way this works. But this is in a very specialist kind of environment, but it's been in use for a while and they're quite excited about it. So some more futuristic kind of things. As you can imagine, when you have these chains and you have transactions that are part of different chains, if you want to query across chains, what do? So people have also talked about having these side chains. There was a talk some time ago in the Bay Area by a guy from some UK company. I think it's a startup that's involved in the side chain business. I also mentioned the chain code portability is an issue. This is the standard thing that comes up when you are trying to allow for multiple kinds of stores to be underneath. Do you give the least common functionality to the chain code? And hence, you can go from that to the super duper one because you are using, let's say you give a key value store kind of API. Then you're going to use a relational system in a dumb way as just a key value store, which doesn't leverage the full power of the SQL system. But if you give the higher level functionality as a standard feature, guess what? And you store a dumb system underneath, use a dumb system underneath like a key value store. Now this layer in between has to compensate for the missing functionality of this underlying simple-minded store. And that means that that layer in between is becoming like a full-blown mega database system with heterogeneous data integration, all sorts of stuff that's been done before, but done by database people. But these are not database people, the guys who are writing this fabric code and so on. So I'm actually, as a result, saying we should go for APIs that are specific to the underlying database and screw portability of the chain code across different databases. Non-determinism, we've talked about. So analytics on the chain code data. This again is a nuisance, right? If you have fancy stuff underneath, but it's not visible to the database system, you have a key and then a bag of bits. That's what these key value stores let you do. And the interpretation of the bag of bits is left up to the guys on top. This is like it's even worse than IMS pre-relational, right? The IMS at least had fields in it. Here it's just a bag of bits, and it's all in the eye of the viewer as to what the actual structure within that thing is. So if you want to do analytics now, you are screwed. You have to now export this thing to a database that's got more interesting stuff in it. And then now you run into this problem because it was a secure environment, now you shout it into some other place, unless you make sure that this other environment will still enforce the rules of the game of that first environment. You also have the other problem, which is OLTP and data warehousing, the delays that are there, and so you don't get to see the latest and all that. So for that reason, also having a relational store underneath will let you then do the analytics in place. Anyway, so for the people that are research-minded, paper writing, this, that, algorithm types people, there's tons of stuff to be done here that's fertile ground for all sorts of interesting things. Any questions?
I think we have time for one or two questions here.
And then we can go out and talk. Huh?
If they're quick.
We have to vacate the place. That's a real problem. 8:30.
Question all the way in the back.
Yeah, so a very quick one. I spent some time reading the Bitcoin original paper, and I didn't understand all the details. But I remember that the reason for the proof of work is precisely because you couldn't trust anybody. And that's why you need to have this.
I made that point clear.
Right.
In the open one, because it's all random people who don't.
So how do you simplify that by knowing that people are who they say they are? What kind of things do you ask
There is more accountability, and even in this environment, like I said, PBFT was used. So you can make different kinds of assumptions. You don't have to trust everybody. You may trust a subset of the people, and there is more knowledge there as to who these people are. And so, yeah, this is still a tailorable thing. That's why even in this version 1, even though it comes with only Kafka, it is an approach where you can plug in anything else also.
Exactly that you ask the nodes to do? I mean, instead of solving a hash problem, what kind of things can you ask?
Oh, they're all trying to bless the contract. This is like in a real world. In the real world, who is doing proof of work, right? So there is enough identity and signing and all that that's being done. So there is more accountability being established because of this notion of endorsement. And you are going to expect endorsers, I mean, you will designate as endorsers more trustworthy people. So it's all wrapped into that.
I'm sorry, folks, we're kind of out of time, so I do have to kind of cut the questions short. But let's please give a round of applause to our speaker, Mohan. Thank you so much.
Thank you.
Thank you very much.
Enjoyed it. Thanks for coming.
We have a gift for you, actually. We got something for you.
Okay.
So it's a beautiful bottle of wine that for you. So
Thank you.
excellent.
Appreciate it.
Got it, Kev? Cool. Let's one more time for Mohan. Thank you so much for coming out. We really appreciate this. Guys, there's pizza left. No, seriously, take the boxes of pizza. If you only want part of a pizza, there's empty boxes underneath. So take the pizza. We're not taking it home. You take it home. Take it home. Thank you so much. We'll see you on July 18th. Appreciate it. Thank you so much.